Good morning, Professor. Me and my friend Lavanya. Today we are going to present the presentation on electricity consumption time series for long horizon forecasting. This is a title for the project, and the subtitle is benchmarking how the electricity is consuming in yearly and hourly. This is a usage of various scenarios. Coming to the abstract, in this we split the data into 80 percentage of training and also 20 percentage of testing. In this we can see that objective methodology, baseline, future model, deep learning, implementations, future work. um, Here objectives can compare on the three models like Sarima, SG Boost and LSTM models. These are only on electric load forecasting. Coming to the methodology, this is all about the trainer and testing data. Baseline, it provides the interpretable, seasonable benchmarking with moderate accuracy. Coming to the future model, HG Boost, it will reboost the nonlinear predictions. And also coming to the deep learning, it captures the LSTM long short term. It gives how MAE and RMSE in the lowest configuration. Implications are only on emissions of the margins and grid flexibility. These are the abstractions we are going to see in further in this project. Background contest. As we know, this work comparing on three models. Challenging are hourly head to head. Forecasting must be precious to cut the event margins, cost, emissions. The models and these are the uses. How the model is used to what, like Sarima is used for electricity water traffic, SG Boost used for the calendar which exits on, LST model is used for the deep sequential patterns. Mm, Trade-offs, Sarima is linear and SG Boost is non-linear. Coming to the LSTM, it computes heavy but powerful having the data. Our approach is it trains 80% of data and text on 20 percentage. This is a dataset overview. These are the time span and completeness. There is no missing values. Coming to the statics, there are mean, standard deviation, and range. Seasonality. This gives clear daily, weekly, and annual cycles of the electricity. Suitability is clean data, like hourly and daily, weekly patterns, how long it takes. These are the algorithms we see on the three models: Sarima algorithm, SG Boost algorithm, and LSTM algorithm. These are the mathematical equations about the Sarima model. It on auto regression. Mm, and this is a HG Boost. This overfit the data in, it gives like a tree model view. uh, that's it, Professor. Now I'm going to handle this project to my friend Lavanya.
Hi, Professor. My name is Lavanya. Now I'm going to explain about the long short-term memory, which is known as the LSTM. This is the algorithm we have used to build our project on the electricity consumption. An LSTM model is a type of the recurrent neutral network that maintains a memory cell and uses the gates to decide what to keep and what to forget, and gives the output uh, on the prediction what we gave it. This lets it long-term range dependencies in a sequence like hourly load, and it gives the next 24 hours of prediction for the electricity consumption. Optimization for performance approach and naive Python and NumPy vectorize and benchmark. And when it's coming to the approach, replace Python loops in the AI forecasting with the NumPy. And for Python, for each time, sum the last lagged values into the coefficient for the NumPy. The build and numerical value to tag the matrix of the each row and the column as shifted view. Compute all the forecast at a once via once matrix vector product, and the loops are 0.26 seconds. And the key takeaways are minimize the Python level loops, use a big batch arrays, generalization, and here the simultaneous data set, the noiseless test, and the noisy test. We have the both navy and vectorized implementation produce a zero forecast error, perfectly recalls the closed form solution. And this is a setup, and this is the we generate the sequence value of starting from the zero with noise, and the expect is the randomness, the one step forecast. And here the um, MSE is approximately 1.002, matching the true noise variances errors systems from the incredible with a white noise. And this is a setup we have used for this test. And the we expect is should reproduce exactly the deterministic AR part. And the key takeaways are the closure from the recovery conforms. The forecasting logic is corrected by constructions, implementation, and array. An extra error on real world data reflects a model misfestication or unmodeled factors, not implication bugs. The real world performs comparison is system load and the household power. Date for the system load data, hourly system load over year, split the overly 1 year data into two parts like 80% train and 20% test. And the result of this is actually we have used the LSTM model for this algorithm for this project. We got the 5.1, and the household power applications level user sample minutely over 4 years. Average hourly is 8 by 20 split, like 80% training and 20% split, and the results are 15.8. And when it's come to the system load, the basic model captures much of the load's interior, and the household demands the higher variability leads. And we have the graphs and the visualization. And the first one is the actual where the forecast. The data depends on the first week of the test data, and the second histogram depends on the forecast of the next predicted 24 hours. And the comparison with the alternative forecasting methods, and this and they're the hold winner algorithms, and the AR5, and the random forest. And the key observation in this data is hold winners underfit the high variability load without the exogenous input, and the random forest slightly beats AR5 in accuracy of 8.4 with 8.9 at the cost of approximately 1 second extra training. It based on the 1 second of training, and the perfect default seasonality fits daily, weekly, annually cycles but lacks without the additional regressors. Trade-off AR5 dominates in the speed with competitive accuracy. Random forest is a balanced midpoint, and with the specialized seasonal tools need careful feature designs to match the baseline performance. And now my friend Pratisha gonna explain about the discussion and conclusion.
Coming to this project, as we know, auto regressions are speed and specialty. Miscon forecast it is closely for least squares and vectorized operations. Interpretedly, like it gives lag coefficient directly shows how past values influence predictions. Applicability like domains and extensions. And also there is some limitations like it can capture the complex modularity and it struggles various trend shifts and also underfit long range dependency or overfit noises, and also Sarima wrappers for weekly and weekly cycles, paths for enhancements. These are the paths which we have regulations and hybrid models, adaptive estimations, automated turnings, and also seasonals. As we have the PIP installments, this is our PIP installment to our project, and have we and this is our data which we have taken for electricity of data set.